Hi, everyone. My name is Laura Shin, and I'm here at the Modular Summit with Christopher Goes, who is the co-founder of Anoma. And we are going to talk all things Anoma.
Thank you for having me.
So Anoma is known for creating this concept of intents. But before we get into all of that, I'm just so curious how you and your co-founders came together.
Well, a long time ago, I competed in a hackathon associated with the Cosmos project. Honestly, at the time, I thought Cosmos was a cool project, but I competed in the hackathon because I needed to pay my New York City rent, and I was really poor, and the hackathon had a nice prize pool. I didn't have a job, so I was just like, I'll compete in a bunch of hackathons, and maybe I can make my rent for a few months. And so I looked for hackathons by prize, and Cosmos Hackathon had, I don't know, like $10,000 prize or something. So I competed in that, and I made some kind of like linkable ring signature based privacy preserving payments Tendermint ABCI application. And uh, later on, kind of having gotten to know the project through the hackathon, later on I ended up chatting with several folks who worked at the Cosmos organization, particularly Bucky, and they offered me a job. And I could take the job either in the US or Berlin, and I kind of wanted to live somewhere else, thought it would be interesting, so I agreed to take it in Berlin. And when I got off the flight to Berlin, or landed in Berlin, I was trying to find Cosmos people in Full Node. And I actually walked into the Full Node building and I walked past Awa. Of course, I didn't know who she was, sitting in an office. And I don't know, for some reason I was kind of confused and I was really jet lagged. I walked in and I asked her, do you work for Cosmos? And at the time she didn't, so she said no. But she was actually like the first person I met in Berlin.
Wow.
So I just walked off the plane and went.
Was fate.
Anyway, this was a long time before we started working on a project together. But at first we were just friends. We went hiking together a bunch, still do. Not enough, but sometimes. We all worked on Cosmos together for a while, and we decided to start a validator company, not really because we wanted to run a validator, but because at the time everyone was worried that there wouldn't be enough validators for proof of stake, sort of deadly terrified of this. Now, no, nobody worries about this, but it was a different time. So we decided to start.
So what year was this?
Boy, this was like 2020, pretty much.
Okay.
2019, 2020. We started a validator company called Cryptium Labs, and that operated for a while. We didn't really like being in the validator business. Occasionally it required driving to the data center at 4 a.m. And you can only do this so many times before you get tired of it. I deeply respect all the people who continue to run validators. We are in your debt. Thank you. But it wasn't for us. So after a while, we sold that to Chorus One. We worked on some other things. I was still working on Cosmos. I worked on IBC at the time. And then at a point, especially once IBC launched, we just kind of got together and we were a little bit, I would say we were just not convinced of some of the directions in which the space was going, and we wanted some time to investigate ourselves what we thought really needed to be built, how to do it. And so we decided to start really working together seriously on Anoma. At first, it was actually called Project X, if you read some very old things, which you probably can't find on the internet anymore, but we didn't know what to call it. So that's the story.
All right. So what is Anoma?
What is Anoma? The answer to this question has developed over time. We started with a very incomplete understanding of what we were trying to build. We've always had this concept in mind of the intent. The concept of the intent actually came from even before Anoma. It didn't really, I don't think Anoma should be credited with inventing the word intent or the concept intent. At most, we helped bring it to the discourse, which I think is helpful, but it really comes from just looking at social systems in the world. And in most social systems in the world, including technological ones, users express some kind of intent when they interact with the system. When you're talking to people and trying to figure out who you should work with on a project, you express some preferences. You express something that looks like an intent. When you type into Google, you express something that looks like an intent. When you open Uber on your phone and select where you are and where you would like to go and what sort of car you want, you're expressing an intent, right? So this concept is not really new, and the word is used in at least very similar ways in UX design and some kinds of social systems theory. And we just wanted to use that, assuming that users are going to have intents when they interact with these kinds of decentralized systems. We wanted to kind of take that concept from the user's perspective and take what we understood of how the technology actually works and try to bridge these together. Because it felt to us at the time that they were really disconnected. That users using these systems, they had things like intents, and the people building these systems were talking about blockchains, and they were talking about smart contracts. They were talking about, certainly useful constituent concepts and parts to form the kind of technological structure, but they were really disconnected from how users saw the system. So to us, intents are helpful as a concept to help bridge these perspectives.
Yeah, it's similar like if you have something that you want to do, and instead of the app just doing it for you, it gives you a list of instructions on how to use the app.
Right.
Yeah.
It's like some of these preferences are arcane. When I write a transaction and send it in MetaMask, the thing that I'm sending to the network says like execute EVM opcode 62, then execute EVM opcode 25, then execute EVM opcode 36. I don't care if you execute EVM opcode 36. I want to get the asset that I want to get or not, or I have some, maybe I want a better price or I want a car that is as fast as possible. I have preferences on a higher level of abstraction than is sort of expressed in this imperative sequence of instructions.
And so what are some intents in DeFi that you feel are like ripe for just turning into, these functions?
I mean, I think it's common, and I hope that we find other use cases than just swapping tokens. But even the simple intent to swap tokens is something that's helpful to express as an intent in kind of a more structured way. One reason that I think that that's particularly helpful is that users right now, they're often sending, their transactions or proto-intents using something like, newer versions of Uniswap or CowSwap. They're sending these proto-intents to like one specific chain or one specific part of the whole blockchain ecosystem. And usually, again, those implicit preferences are more specific than the preferences users actually have. For example, if I want to swap for USDC, I just care about, USDC ultimately is like issued by Circle, so I care about getting USDC somewhere where Circle will accept it. That's going to be less specific than like just on Ethereum or just on Solana, at least most of the time. So what I really want to say as a user, I think, or at least what I would want to say as a user is, I have some ETH on Ethereum, I have some ETH on a rollup, I have like some asset somewhere. I know where my asset is at some specific place because I already have it. And I want to swap it for USDC in like any of these, domains which Circle supports, which are very well trusted and which are like fine for my, probably what I'm doing. And I just want to get the best price. I want to get like at least a certain amount of USDC. And it would be great from my perspective if this sort of network, perhaps with like lots of little automated parts, lots of different solvers, lots of liquidity sharing going on, intent gossip, would figure out where specifically that should be executed in order to satisfy my preferences as best as possible. Now, right now, this UX is not quite available. I mean, some of these aggregators like 1inch are starting to approach it. I think there's the sort of convergence of the market a little bit, but it's still quite fragmented.
And Anoma also has some suggestions of new types of functions that could be accomplished with this. For example, one of them is public signal.
Right.
Can you talk about some
So
of these
Anoma
ideas?
is not just intents. I think that's like, a word that we've become known for. But in fact, the concept of intents is very general and broad. There are other intent systems. It's not just Anoma. We've kind of published some mathematical definitions that try to capture what exactly that means. But Anoma includes several other ingredients that we think are necessary to make this technology sort of actually useful for lots of real-world systems. And two of those important ingredients are what we call information flow control and what we call heterogeneous trust. So information flow control is kind of like, you can think of it as the inverse side of privacy rather than thinking about what you want to hide, which is not really a choice you make when interacting with digital systems. Information flow control allows you to think and reason about what you want to reveal, and not only what you individually want to reveal, but what you want other parties to reveal or not to reveal as information travels around the system. For example, I might, let's say I'm engaging in some kind of just some swap where I'm sending assets to somebody and I want to enlist a solver to help me do that, to help me find a counterparty. I might have a particular solver that I trust to keep some of my information private because I have to reveal some information to the solver in order to allow them to find a counterparty for me. But I don't want that solver to forward that information to like any other parties except maybe one or two other solvers that I trust. So I want to be able to express very clearly to the solver what I do and do not want them to reveal. Now, there are different degrees of like enforceability for different kinds of preferences here. Of course, the best case is where I can just do all the computation myself and make a zero knowledge proof, or where I can encode something using strong cryptography like MPC or FHE, or even a TEE if you're willing to make certain assumptions. But even so, there are a lot of cases where I just want to be able to reason clearly about what kinds of information I want to go around the network, what kinds I don't. And information flow control is this great like tool from distributed systems literature that can, I think, help us reason about that. I will get to multi-chat, I promise. The other part is heterogeneous trust. And heterogeneous trust is the idea that users around the system are not going to agree on like one central source of trust. They're not going to agree on one global blockchain, not going to agree on one world computer, not only in general, but also for like different things. Like as a user, if I'm sending a payment of $5 for coffee versus sending a payment of $500,000 for a house, these just require very different levels of security, right? I don't think that we can have a sort of content neutral system or topology. We need to take into account what the user is actually trying to do and who they're actually trying to interact with and who they trust. So heterogeneous trust concretely manifests in how the Anoma node software actually works. The Anoma node software, rather than running one particular chain or one particular trust zone, is sort of multi-chain native or heterogeneous trust native. So you start the node and you can configure it with like which chains you would like to participate in. And intents, even from the demand side, can express, I trust such and such validators. I would be happy to send my intent to any chain where like enough of them were signing, right? So you can kind of express these very specific trust preferences, and intents express this demand, which can be seen by the supply side, and they can see which blocks to produce. So this kind of heterogeneous trust and information flow control is important because it enables a very different class of applications that you might not even think is part of blockchains, at least as they've been developed so far. One of these applications is multi-chat. And the basic idea behind multi-chat is to build a decentralized version of Discord. So Discord is a very sophisticated, like a group chat software. And in particular, it's sophisticated because it has complex nested permission structures. And these permission structures, creating channels, saying who can post in certain channels, how often they can post, what they can post, allow communities to craft a kind of structure, a topology of discourse, which fits what they're trying to do, who they want to be able to interact with, inside their community in what ways. I think that kind of permissions, the kind of flexibility in permission structure is very important. But one reason that it's difficult to decentralize discourse is that, well, you're sending like chat messages. Like you can't send those all as $50 transactions to a blockchain. That's super expensive. But if instead you had the ability to express these kinds of heterogeneous trust guarantees that you want, like for example, maybe some of the people who are participating in the channel, like who are actually sending the messages, are also the people running consensus, or also the people storing the data. So with Anoma, you can build a kind of decentralized version of Discord that expresses very precisely who is supposed to perform what roles in the system, and who is supposed to perform what roles can depend on like the semantics, like who's actually in the chat. Because if I'm in the chat, then I have some reason to want to store the data. I have a reason to want the system to work. So it allows you to create these kind of program in some sense who will perform certain roles in a way that's incentive aligned with the actual application.
And for these intents, like how do messages get sent around the peer-to-peer system?
Right. So Anoma has this sort of, in some sense, it's a global peer-to-peer network, but it's not everyone is sending every kind of message or receiving every kind of message. So we have a system we call sovereign domains, where there's like a global overlay network, and then a bunch of individual domains by nodes which like want to gossip or share information about a particular thing, like a particular type of intent. There might be a domain for a particular multi-chat server, or even a particular multi-chat channel, like even something within it. And Anoma sort of reworks some of the basic layers of network infrastructure to organize them on the basis of cryptographic identity instead of physical identity. So when you send a message in the Anoma peer-to-peer layer, you send it to some it's like a generalized public key, you could say. And then the network layer, all the nodes, store information about like which physical device that should actually be sent to. So for example, if we're in the same room at Modular Summit on the Wi-Fi, and you and I are in a multi-chat server together, we're using the Anoma peer-to-peer layer, and I send a message to you, it doesn't need to leave this room, right? The network layer is smart enough to figure out that, oh, I'm trying to send a message to Laura's public key, and Laura's public key's device has checked in recently, and it's like on this IP address. So we don't need to go to this global internet all of the time.
Okay. So yeah, it's kind of smart that way. Generally, like when a user is trying to express an intent, how can they trust that the system is resolving it in a way that is in their best interest?
That is a very good question. And this also relates to things like MEV, maybe, where MEV is the other side of this question, where it seems like the system is not acting in users' best interests.
Right.
So the answer is, at least as far as we've figured out, that the user really has to, or at least some device acting on their behalf, really has to pay attention to what's going on. So for example, as a user, ultimately the intents that I'm authoring are like the source of valuable liquidity to the system. So I have this negotiating leverage, but in order to make that negotiating leverage useful, in order to make it kind of align the system with my interests, I need to measure what's going on. Like when I send intents to different solvers over time, I need to measure if I express my preferences clearly, I can measure, did they satisfy my preferences as well as another solver did. I can measure, I can compare these different solvers, different, choices of specific network topology, and select over time who's acting in my best interest. So you could think of this as a kind of a form of reputation network or trust network. And it is very application dependent. If I might often just want to kind of describe some of my actual friendships, my actual, high trust relationships to this network, such that I can use my friends as solvers, at least when they're available. And in some other cases, maybe they're, a bit more centralized entities solving for 4x or something like this. And they've published a bunch of rules which they adhere to, and there's some kind of public auditability of all of these messages going around the system, something a little bit similar to what DYDX does with its validators these days, for example, where, in conjunction with a bunch of other users, periodically, we get together and compare the histories of the messages that we've sent to the solver and see, like, does the solver appear to be introducing sort of arbitrary network latency delays? Do they appear to be exploiting MEV, or so to speak, not acting in our best interest or not? And if they appear to be, we kind of get together and say, oh yeah, the solver is screwing us over. We're going away. We're going to go to a different solver. And if this threat is credible, it's almost the threat of forking, right? The threat of like sending your intents somewhere else. If this threat is credible, then the solver faces this choice of, do I, extract value, but then users will send their intent somewhere else in the future, or do I, take enough to support my operations, but generally not take too much, mostly adhere to the user's preferences, and thus keep my business going, at least in principle, indefinitely. And we think that, we want to change this one-shot game structure into a repeated game structure. That's ultimately the only way.
Yeah, it reminds me of like reviews on the internet, but
Exactly. I mean, it's quite similar. I think we can't really avoid like really trying to build the distributed web of trust. That quest was given up. PGP attempted it in the 80s and 90s, and I think they had a lot of good ideas, but they didn't have everything to put things together, and we're not there yet, but I think we have many more of the components.
Right. So another component of Anoma is the resource machine. Can you explain what that is?
Right. So the resource machine is our way of representing intents. And in the way we describe them, intents consist of two parts. They consist of constraints and preferences. Constraints are conditions which must be satisfied in order for your intent to be matched. So for example, if I want a car from my hotel in Brussels to this event venue, I would express that as a constraint. If the car is driving somewhere else, like I don't want it. Right? Whereas a preference might be something like, I want like the closest car, like I want a car as fast as possible. But I don't know, maybe a constraint is I want a car in like less than 20 minutes, otherwise it's not useful. But I don't know exactly, when the car will be available, right? If I say I only want a car in the next 1 minute, maybe there's just no car. So I want to express this kind of scalar preference. And the resource machine provides a way to express both the constraint and this preference, and express them in a way which allows for information flow control and full composability, or intent level composability, such that a solver can take intent A and intent B and match them together and produce an intent C which isn't fully balanced. Like maybe intent A is like swap asset 1 for asset 2, intent B is swap asset 2 for asset 3. And so intent C is swap asset 1 for asset 3, but some solving has been performed here. So these solvers can kind of collaborate, can forward these intents around. This kind of compositionality seems to us like it would be very important for good user experience and just good sort of market structure efficiency.
And how does settlement work in Anoma?
How does settlement work? So I think it's always important to me to kind of reinforce that Anoma is an interface, not an intermediary. So Anoma is not a specific place, right? It's not like one blockchain or one, even distributed or decentralized set of parties on the network that you have to send your intents to. Anoma is sort of, it's a protocol, and it's like a distributed network, but there's no particular center, no particular root of trust in that network. And in Anoma, the resource machine is compatible with settlement basically anywhere. Now there will be different specific execution costs. For example, we have this concept we call a protocol adapter, which is a smart contract that could be deployed on the Ethereum layer 1, deployed on rollups, even written in something other than the EVM, which is capable of verifying resource machine state transitions, intent settlement, and in some cases even executing them or emulating the resource machine. Then this protocol adapter will eventually be deployed on Ethereum and Solana and layer 2's rollups. There will be different levels of specific operational efficiency, but it's compatible in principle with any existing blockchain as a settlement layer. So it really is up to the users in the end, like where do the users want to settle? And with all of these intents, you have this, what I would think of at least as a distributed scheduling problem. You want to select users' intents that touch state, which is related to each other, and settle those in one place, and settle intents which touch state that is unrelated to each other in different places. So then you don't pay as much for ordering.
Okay, so here we are at this Modular Summit, and obviously Celestia is a focus. So how would Anoma work with Celestia?
Right. So another part of Anoma is something we call service commitments. And service commitments are a sort of declarative, explicit way for nodes and different parties around the network, particularly validators, storage providers, sequencers, solvers, to make commitments as to what services they're going to perform. And users who have these commitments can then measure, how are these services being performed over time. So for example, Celestia, or data availability layers, as we would understand them in this language of service commitments, are providing two services kind of coupled together. They're providing an ordering service, they're ordering transactions, and they're providing like a temporary or fixed term data storage service, data, which is often called data availability. So I think, some applications, it doesn't maybe always make sense for those services to be coupled. It only makes sense sometimes. But for applications for which it makes sense for those services to be coupled, I think Celestia would be like a really good example of a service provider, which is optimized for providing these specific coupled services really well. Like they've put a lot of resources into building data availability sampling. I think they even announced at this event like a data availability sampling light client, which is awesome. They have, Tendermint for ordering, Common PFT. So, Anoma applications would be compatible with Celestia as a provider for those services. And users who want to use Celestia can sort of select that in their application configuration without really doing a lot of extra work other than choosing it.
And how does Anoma work cross-chain? Like when you're deployed on all of those, is it possible to work cross-chain?
Yes. So we've built a kind of way to synchronize state cross-chain. You could think of it as, in some sense, like, I guess, a bit similar to IBC in some ways, but operating at a lower level of the system, operating at the state architecture level instead of just the like inter-blockchain message passing level, and using what we call our controller system, which we have a paper about on our website. You can synchronize state across all of these different domains. So in your intent, you can say, oh, I want to swap, my ETH for USDC on Solana, USDC on Ethereum, USDC on Celestia, I don't know. And you can express that in a way that sort of unambiguously identifies the chain which you're trying to receive the asset on, but also in a way which says I could receive it on like many of these different chains. And you can express an intent where, the asset that you're trying to get doesn't even exist yet on the chain that you're trying to get it on. But by expressing that intent, you create this clear statement of preferences, which can be taken by a solver. Maybe the solver goes and moves the asset around the chain you're trying to get it on, and then the solver can match your intent. So this kind of state synchronization system is working in the background. It's tracking provenance, it's tracking where state comes from. It's doing, a bunch of complex distributed system stuff to make sure that the system is safe and capable of tolerating Byzantine portions without breaking the security of other parts of the network. But users and application developers hopefully shouldn't really need to think about that. Like if you think of another database system, think of like a distributed SQL database or a distributed like Google's Spanner, and even MongoDB, which used to kind of suck, but I think they've gotten better. You don't really think about as a developer like which server your data is on. That would be a little bit arcane. You want the system to handle that for you. And we think that this is mostly the same for blockchain or Anoma application developers, except that they will want to reason about what trust assumptions they're making. So we've built this, you do know which chain is securing your application or securing different parts of your application state, but you don't have to like manually send messages to other chains. That seems, at least in our view, unnecessary in order to perform this kind of cross-chain intent state synchronization application model.
And a little bit like out of the philosophy of what Anoma is about.
Right.
So what are the next steps for Anoma? Like what are the next big milestones you'd like to hit?
What are the next? We're hoping to release the testnet later this year, hopefully very soon, but I don't promise dates anymore. My engineers promise dates. Their estimates are more accurate these days, so, but I think it will happen soon. And really, we're just looking to kind of figure out how we can best contribute to many other ecosystems, to the Ethereum ecosystem, to the modular ecosystem, to the Cosmos ecosystem. We want Anoma to be like compatible with all of these things. We really care about applications. We want to give applications the right abstraction layer and to allow those applications to work with any and all existing service providers for data availability, for ordering, for sequencing, for solving, et cetera, et cetera. Most of these service providers already exist in the world. And, we could, I guess, try to recruit some other service providers, but that seems unnecessary. We'd much rather work with people who are already doing this and kind of make it easier for everyone to interoperate and to support real applications of this technology. So we're looking for collaboration.
Great. All right. Well, I think that's everything. Is there anything else you would want to chat about?
I'd just like to thank you and the organizers of this event. It's a very cool venue. I like the modular theme. And yeah, I'd also like to invite critique of Anoma. We really try to publish our research and publish even our philosophy, our sort of design ideals. And the best resource for anyone trying to seriously pursue a project or trying to bring something interesting to the world is a good critic. And we don't see enough of that in the blockchain ecosystem. So critics welcome.
Great. Well, thank you so much.
Thank you.